Okay, in this lesson we're going to have a look at area and to explain or make sure we know what area is and how we can work with that quantity. So the area of a shape is the surface inside a shape. I try to avoid using the word space because I'm going to reserve that for the idea of like a box, like three-dimensional space. We don't usually think of space as being flat, so I'm not going to use the word space. I'm just going to use the idea of the area of a shape is the surface inside a set of lines. So the key thing is here, the area is to do with the surface inside, and perimeter is to do with the surface or the edge all the way along the outside. And that's the key thing to tell the difference between area and perimeter. And in looking at that surface inside, we're usually asking how many squares or little boxes could we count or fit inside it. And we usually use like squares, a box that's 1 centimeter by 1 centimeter, or a millimeter by a millimeter, or a meter by a meter. It depends how big the shape is. So at the moment I'm going to look at these boxes are all a centimetre square, but we're just going to call them units at the moment because you may be using smaller squares or bigger squares. Okay, so let's have a look at these four shapes. Can we work out the area of each of the shapes? And you may already know the answer to most of these, and that's fine. So let's have a look at this blue rectangle here. We can see quite clearly that inside we can count 1, 2, 3, 4, 5, 6, 7, 8, and therefore we can say that the area here is 8 square units. We're going to write out area in full equals 8. I'm going to use the word units because and put a little square. Now remember that's just like a square number. This is to show that we're actually dealing literally with squares we're talking about because they can fit 8 of them inside. So you may find if each of these was 1 centimeter wide, we might use 8 cm with a little 2 square centimeters or something else. But for the moment, just for this, I'm going to write down just square units. Okay, and that means boxes of any size. Let's have a look at the second one. So we don't have a rectangle, but we can still, now you don't have to write down the numbers. You could, sometimes it's just as good, it's still good to put your pen or pencil down and literally count the dots. 1, 2, 3, 4, 5, 6, 7, 8. Again, we can say the area here equals 8 square units. Did you anticipate that? Did you think that the areas were the same? In some ways, the green shape looks a bit bigger because it's wider, but there's this gap in the middle. So sometimes we can make a mistake in judging things with our eye. That's why it's good to count. So what happens when there's sloping edges or curved edges? How do we deal with that? Well, let's look at this triangle. There are some special cases here because what I'm going to do is I'm going to number all the boxes that are fully inside this triangle. So there's 3, 4, 5, and 6. Okay, so I've got 6 full boxes, and this is a special case because see this here, this box up here, and this part of the triangle that's inside it is exactly half a square. So that's kind of a half. And so is this one. So what we can do is we can say of these two, well, we'll count that as 1. So that's us up to 7. And here's a half, and here's a half. That's us got another 1. That's us up to 8. So again, the area here is 8 square units. Did you think that the area of that was the same? We've got 3 shapes and all of the areas are the same. The surface inside takes up the same number of boxes. They're just the boxes are kind of arranged slightly differently. So when you've got lines that cut a square exactly in half, it's kind of easier to tell. Now lastly, here's this oval shape, and this can apply to any old shape that doesn't kind of fit nicely. It doesn't have squares nicely inside it. And one of the ways we can roughly estimate this, there are very complicated, sometimes formulas that we can use to be more exact. But if you want a rough guide, one of the ways you can do it is to say if more than half of if there's the if more than half of the box is inside the shape, count it as 1, and if less than half of the box is inside, count it as 0. Okay, so in this, I'm going to start at the top. You'll notice that, see this square here, there's only a little bit in it, so we're not going to count that as inside. Then this next shape here, okay, I'm just going to use a dot for say, yep, more than half of that box is inside. What about this one here? Yep, more than half of it's inside. And this one over here, there's only a tiny bit in, so I'm not going to count it. Look at the next row. Not in, and only a little bit, so we'll count that as not in. Look at the next row. Not enough, and it's close, it's nearly a half, but it's not quite, so we're not going to count that. We're going to count this, we're going to count this, and we're not going to count this. Look at the next row. We're not going to count this one here, but we'll count this, and we'll count this because it's almost all in. The next one's almost all out, and the two at the bottom, not very much in them, so we're not going to count them at all. 1, 2, 3, 4, 5, 6, 7, 8. Do you know what? The area of this shape I'm going to call 8 as well. Now, 8 units, square units. It's not exact, and I suspect that the area in the end would be a bit more than 8 because we've kind of missed out chunks. Usually this idea is that it overall it kind of cancels out things, so it's a very rough guide. Sometimes it can be a bit out, but we're going to use that as our kind of starting point for shapes that don't have straight edges. Okay, so area is the surface inside. We can count the number of boxes it takes up, and we can write it out in terms of this kind of working here. Let's have a look at a couple of applications and draw 3 different shapes, all with an area of 8 centimeters. Well, let's do what? I'm going to change that because all of mine were 8. So let's make it 12. No, in fact, let's just keep it simple, make it 6, okay? 6 square centimeters. Keep it nice and small, just so that it's a different number than mine. So we could, if I'm asking you to draw 3 different shapes, then they could all be rectangles, for instance, but let's try and be a bit creative. Let's try and draw one rectangle that's got an area of 6. So in other words, we have to think about where we're going with this. So if I were to draw a line going down, say by 3, that's 3 boxes down. If I make a line that goes 2 boxes along, and then I join them all up, then that's like there's 6 boxes in there. So that's an area of 6. Okay, I'm going to try and draw a shape that's kind of like an L shape or a bit of a block with something cut out of it. If I were to do something like that, so like what I've done, I want to go along like this, but do you notice if I count 1, 2, there's only 5 in there. So what I need to do is I'm going to make that my line there, and we're going to add an extra block at the top. It's really important that you don't think of this as perimeter. We're not asking for 6 lines around the edge. We're asking to make sure there's 6 boxes inside your shape. Okay, it doesn't matter how many lines you use to make it around the edge. So let's get 6 boxes inside. Let's just check that. 1, 2, 3, 4, 5, 6. I'm going to write down area equals 6 square units. Now, I've said 6 square centimeters because my boxes are going to represent that, but in all cases, it's absolutely fine just to, whatever size of squares you're using, we just write units at the moment. Area equals 6 square units. What could I do? Could you, let's not try and make it too random, but what I'll do, you see these sloping lines? Let's see if I can introduce a wee bit of a sloping line through a couple of them. So let's have a look at, you have to go right through the corner of each shape. If I did a line like that. Okay, say we go down here. How many boxes are in this bit here? Look, in the top of the shape. So I've got one box, and remember these two are like half boxes. So I've got 2 boxes in all of that. So I need another 4. So what I'm going to do is just extend it down so that it goes down to there and along and up. Okay, so it's interesting to explore that kind of diagonal line through the corners of the squares, because it's easy to maybe count up in halves a little bit. So let me just check that one, because that's a bit weird. I've got, there's my half, and half makes 1. I've got 2, 3, 4, 5 and 6. Yep, my area is still 6 square units. Okay, so I can explore the idea of an area with different looking shapes, and that's fun. The last one here, here's a wee puzzle. Draw a shape with 2 lines of symmetry and an area of 14 square centimetres. 2 lines of symmetry. You might not have covered symmetry too much, but what we're looking for is basically kind of dotted lines. So a line of symmetry might go kind of along the way, like that, and it also might go up and down the way like that. So rectangles have a line of symmetry like that, but not just rectangles. So you could be a bit creative. So if I were to think about an area of 14, what we have to think about is that on each half, on the left and the right, there's going to have to be 7 boxes. And yeah, I think, yeah. So I'm just thinking of that. I put 14. I'm actually going to make it 20 instead, for reasons which I will not explain. So let's make this 20. So what that means is basically we have to make sure there's 10 boxes to the left and 10 boxes to the right of this line here. Okay, and also up and down, if there's a line of symmetry, we need to make sure there's kind of 10 above this line here and 10 below. So we've got to make sure, in actual fact, we really need to have 5 boxes in each quarter, basically. Okay, so let's see if we can make sure that we've got all of that going on in our shape. It's a wee bit tricky, so I'm going to draw a shape that's got, look, I'm going to draw, oops, let's not draw that one. Let's get the lines going. Here we go. So if I go from here along and just draw a shape that's got 5 boxes, so I'm going to do that. There we go. This shape has got 5 boxes, which means that if I reflect it over here, the line of symmetry means it's like a mirror image on the other side here. There. So that's got a reflection there. 5 and 5 is 10, so that's good. I've got 10 boxes above the line, and basically what I have to do is reflect it like a mirror underneath. That's 5 there, and then keep going. Now there's lots of possible solutions to that. I'm just picking one, and if you count the number of boxes just to check and see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. The area equals 20. So every time you do a shape, make sure you write down clearly what its area is. And I've, again, well, I started off with square centimetres. I'm just going to remind you that it's okay to use square units. Okay, so a wee bit of instruction there on using all of this. You can go and practice the questions, but I have got a challenge I'd like you to come back to once you've practiced it, and that is this. There's a shape that's got an area of 16, okay? It's got no curved edges, and so it's really just what I want you to do is kind of block shapes, you know, so that no sloping edges, nothing like that, just kind of a shape that where it goes along the edges of all these lines. So say I managed to draw a shape that had 16 boxes in it. That's actually quite big, so you might have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I can add another 2 up here. So I think roughly that should be 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 16. Area 16. Now I could count that perimeter. Let me do it. Just quickly. The perimeter, remember, is the length of all the lines around it. So if I start here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this shape here has an area of 16 square units and a perimeter of 24 units. The question is, could you make a shape that's got more of a perimeter, that's got a bigger number of edges? And could you make a shape that's got a smaller perimeter? And could you keep working it out until you can say, do you know what, I don't think I can get any bigger, and I don't think I can get any smaller. What are those numbers? As a wee challenge for you. Okay, thanks for listening. Hope that's been helpful. You go and practice some yourself.